A pleasant morning to all of you. Today I'm going to deliver a presentation on nuclear fission. I am Dr. Ancemma Joseph, Assistant Professor, Department of Physics, Fatima College. Can you see some pictures? What are these pictures? What do they depict? These are nuclear power reactors. What are they? They are the largest source of electricity. The enormous energy generated from nuclear reactions is utilized to heat water to produce steam, which is then used to generate electricity. So these are the world's largest, Asia's largest reactor, and the third one is the reactor in India. So what type of nuclear reactions occur in nuclear reactors? They are nuclear fission reactions. So at the end of this presentation, you should be able to understand what is nuclear fission and what are the basic types of it. That is the learning outcome expected out of this presentation. So how do we define nuclear fission reaction? It is the reaction where a large nucleus is bombarded with a small particle which results into the fragmentation of the large nucleus, and an enormous amount of energy is released out of this reaction. So the beautiful animation describes the fission reaction of uranium. Uranium is the large nucleus which gets bombarded with a small particle which is nothing but neutron, as a result of which uranium gets fragmented into two other smaller nuclei and several neutrons, and a large amount of energy gets released. So this is how we define nuclear fission. And it is Enrico Fermi, the person behind the discovery of nuclear fission reaction. So as we look into the nuclear fission of uranium-235, a neutron bombards with uranium-235, an unstable nucleus of uranium-236 results there, but since it is unstable, it immediately undergoes fission into two smaller nuclei. They are krypton and barium, and three neutrons are released to bombard more of the uranium-235. So this is the basic equation of the nuclear fission reaction of uranium-235. Now, this fission reaction has three general steps. At the first step, there happens the initiation, the reaction of a single atom. It starts the chain reaction, that is uranium-235 getting bombarded with neutron. The second step is the propagation, where there is an unstable nucleus which is uranium-236, and this unstable nucleus releases the neutrons that initiate other fissions via the fragmentation of itself. And the third step is the termination, where an enormous amount of energy is released. So generally speaking, the fission reaction could be categorized into two main types. One is the controlled fission reaction and the other is uncontrolled fission reaction. In the controlled fission reaction, the number of neutrons is kept constant by absorbing the extra neutrons, and the energy released is tapped to produce steam to generate electricity. Whereas in the uncontrolled fission reaction, the progression of neutrons is geometric, in the sense three neutrons released could go and bombard three more uranium nuclei, resulting in 9 neutrons. Further, this 9 neutrons go and bombard 9 more uranium atoms, and this results in an uncontrolled fission reaction and a devastating energy released, and that is what we call as nuclear bombs. So the types of nuclear fission based on the neutrons, the types of neutrons could be basically divided into 5 types: thermal fission, fast fission, charged particle fission, photofission, and ternary fission. So to understand the types of the fission reaction, we should first understand what is a thermal neutron and what is the fast neutron, and how could we differentiate between these two types. So when I say thermal neutron, it is a free neutron that has got energy in the order of 0.025 electron volt. Whereas in a free neutron, when the energy is in the order of 1 to 20 mega electron volt, it is called as fast neutron. So fast neutron has got a very high velocity, 2 into 10 to the power 4 kilometer per second, whereas here in thermal neutron it is only 2.2 kilometer per second. And if we look into the equilibrium condition of these neutron with the ambient molecules, the thermal neutron remains in thermal equilibrium with the ambient molecules at normal temperature and pressure, whereas the stability is not there in the fast neutron. Also, this thermal neutron, they offer high fission cross section towards uranium-235, and fast neutron, they offer very low fission cross section. So like this we can differentiate the thermal and the fast neutron. Now the first type of thermal fission could be defined as, it is that type of fission where a thermal neutron adds negligible energy to the fissionable nucleus and the fission of the nuclei results in the compound nuclei of even structure. And the best example could be the fission of uranium-235 and plutonium-239. So we could see that when the uranium gets bombarded, uranium-235 gets bombarded with neutron, we see that there are barium and krypton resulting in. So we can see that their atomic number is even. Whereas in plutonium reaction, if you look into the equation of reaction, again the resultants, what are they? Xenon and zirconium, they are of even structure, again 54 and 40. So these type of compound nuclei with even atomic number shows thermal fission reaction. Now the second type of fission is the fast fission, where the other isotopes of uranium would form compound nuclei of even odd structure. So the best example could be the fission reaction of uranium-238. So we can see that this uranium-238 fission reaction results in the fragmentation of uranium-239 to neptunium and plutonium. So the atomic number is 93 and 94. So one is odd and another is even. So when such compound nuclei gets formed, we call them as fast fission reaction. Now the third type is the charged particle fission reaction, wherein the elements with atomic number greater than 90, they show fission process with protons, deuterons and alpha particles. So when such charged particles could create fission reaction, they are called as charged particle fission reaction. And when the same type of fission reaction results from high energy photons, and when high energy photons induce fission in heavier elements, they call them as photofission. The example is uranium-238 fission by 5.1 mega electron volt gamma rays, and thorium fission also results due to X-rays. And this is the picture which I have taken from Wikipedia. The photofission investigation carried out by the scientist E.W. Titterton and his co-workers in 1950 using X-rays from synchrotron of energy 24 mega electron volt. So now that we have learnt up to 4 different types of fission reaction, wherein the fragmentation of a larger nuclei results in 2 smaller nuclei. Now the fifth type of nuclear fission reaction is ternary fission, which was predicted by R. Present in the year 1941, wherein there is a possibility of tripartition, that is, division of excited heavy nucleus into three nuclei of comparable masses. So this happens in uranium-235 bombardment also, when the bombardment happens with that of a slow neutron. We found that there is a third particle emission also, which is nothing but an alpha particle emission. So this is the best example which could be given for ternary fission. And there are two more types, true ternary fission, wherein three nearly equal size charged fragments they result. But these reactions are very rare. They happen in about 1 in 100 million fission events. And there is even this quaternary fission, 1 in 10 million fissions, where 4 charged particles are seen. So now that we have seen what is fission reaction, what are the basic types of fission reaction, 5 different types, we can go and visualize a beautiful video on the nuclear fission reaction from atom to reactor through this link. Thank you. Thank you one and all.